Hey everybody, today we'll do another video, and today we will do probably the last problem in the area of convolutions and continuous time signal. And then probably I will do a discrete time signal after this. But I think that probably this is going to be the last one on time, continuous time. So we will, this is the definition of the convolution. So you got a certain signal of generated by these two functions. And the definition is that, right? So from negative infinity to positive infinity, taking the integral of these two signals, right? And one being shift, one of those being shift and flipped, right? That's why we use the term flipping and shifting on those functions, on those signals, right? So remember, we're dealing with signals. So now the one that we're doing, it look like this. So this one look like this. It looked like this. So this is t, right? Of course, this is negative t, but it doesn't matter. But the height over here is 2, right? That's important to know, right? The height is 2. Okay, so that's one of them. And also this number here is also important to know. And then we have the other signal that this look like this. It goes like this and drops like that, and that is also 2 right there. And so this is a function of t, right? And so this, I call it h of t. H of t, right? T, and this right here, I can call it x of t. Now, as we done in the last videos, that the first step is to identify which one we shifted, which one we flipped in, and another question that that probably many people will have is like, how do I know how much I am shifting, right? So because the shifting is important, the flipping is just flipping, right? So, but the shifting is important. That is basically very important number right there. So how we do that, right? So in this case, we shifting this. I am shifting this function. First, step one is flipping, right? That's flipping. So we flip that to like that, right? And that becomes t minus 2. And this is t, right? Now, if you notice that, so t minus 2, right? Now, and this is a function now of tau. Tau, and this is h of minus tau, right? We flip it. It's like a multiplied by a negative 1. You flip it to the other side, and then you get this. Now, right here. So now this is the question, right? So why am I shifting by this, right? So that's the question that somebody may ask. Why am I shifting by this number? Well, this is the when we look, that's the maximum that this signal can go, right, on the t-axis. After this, it doesn't matter. This is 0, and also over here it is 0. So I'm taking from 0 to 2. That's the shifting. And how do I determine that? Well, let's say, for example, that t, right? So t minus 2 is equal to a certain number, to a certain variable, dummy variable, which is now in this case tau. Now, okay, so how do I do that? Remember, right here I have a t minus tau. This is actually representing this. So how do I make it look this to look like this? Well, I have to do a little algebra here. So t subtract tau on both sides, right? And I get t minus 2 minus tau is equal to 0. Now I add 2 on both sides, right? Add 2 on both sides. And when I do that, I get that t minus tau is equal to 2. Now you can see that why I am shifting it, right? I am shifting 2 because that is the number that this expression is equal to. Now, remember from basic algebra that if you have a negative and a number, if it's positive and number is shifting, this is a negative. If that is negative, then becomes a negative this side, right? For example, right here, if this was 2, negative 2, right? Positive 2. If I take it to the other side, this is going to become a negative 2 on this side, right? So, which means that in that case, it's going to be, if I shift it to the other side, if I had an original like this, and I shift it, and I flip it first, and I shift it, this will be end up over here. That will count as a negative 2, right? That's how we do, from basic algebra. But anyway, so that's how we shift and flip, and that's how we know how much we shifted and flipping, right? And flipping, like I say, flipping is not an issue. Flipping, just flip to the other side, and shifting is the one that requires this a little understanding of what that t minus tau is equal to, right? So now what I'm going to do is take this signal and start doing the process. So this is 2, right? And also this becomes right here. This is x of tau. Everything becomes x of tau now, right? So this is tau, right? And this is 2, right? Now what I will do is I will move this forward, right? I will move this forward in this. So this is 2, right? So I will move it this to this, right? I will move t to actually 1 right there, right? So if I move t to 1, that means that this will be, it's still sitting like this. Right? So now this is not the scale, so that's why I make it bigger right here. But you can get the idea, right? So this is the highest 2, right? The height of that is 2. Now this right now is t minus 2, right? It's still sitting at 1, a negative 1 now, but this advanced to positive 1. So this t right here is at positive 1. Now, as you can see that right now I already have an overlap, right? So the overlap is sitting right here. All right, that's the overlap. What if I shift it back here and start sliding? Well, then all this area over here will be equal to 0 until it reaches that one. All right, so that's the first overlapping. Now, so if that's the first overlapping, so that means that t minus 2 is not even there yet, right? So it doesn't count. This whole area is 0. This 0. The only area that counts is this one. So what I will do is integrate from 0 to t, right? Now, what is the height of that? The height of that is 2 of this, right? This actually is, because this is the one, but this is the one that I flipped and shift. That represents that, right? But then I have to be careful because over here I am not dealing with a rectangle. I am dealing with this signal that looked like this, which is called a ramp signal. So now I cannot say that that I will take this signal and just do it regular, right? I cannot do that. Multiply the two signals and you know, and no, I cannot do that. What I can do right now, is make the assumption that this one is similar to y equal mx plus b, so which is a ramp. It's like a slope. So when I do that, I see that this is tau. This is a tau axis. So I see that this over here at 1, that means that probably at the point the signal is 1. When t is 1, the signal is 1 at that point. So I can say that this is 2, right? So this is 2. This is the one that I'm counting. This one I am not counting. I see that there's a ramp here. So because there is a ramp, that is like a slope, right? So what I do is I do t, right? And then I do minus, right? Minus y because it's in that direction, going in that direction, right? Negative, going like a slope is a negative. And then what is it? It's the tau, right? So that at that point is tau, right? Why? Because this right here is represented 1 tau at that moment. Over here, the value is the tau axis, that is maximum, is 2 tau. But I am at this point, right? So what I do is the following. So, and I say d tau, right? So now I do the integration. This becomes what? This becomes the integral from 0 to t, and then I distribute that inside, and I get 2t minus 2 tau, right? And then integrating all that, right, with respect to tau, and this is a t. It's very easy to make mistakes right here. This is a t. T is like a constant right now. It's not a variable. This one will change. This will not change, right? So now, of course, it will change eventually. But when I do the integration, I am treating this as a constant. That's what I'm trying to say. Okay, so what I will do is, so I integrate that, and I get 2t times tau, right? Because I integrate with respect to tau, minus 2 tau squared, and of course I divide by the exponent, and that cancels out, right? And that integral is equal to 2t times tau minus tau squared from 0 to t, right? So now tau is going to be replaced by t, and that's why I say before that t is going to change eventually, but t is being treated as a constant. That's why I want you to understand. right? So t, this is now. All right. So when I substitute that, right? So I substitute t, and I will do it right here. So I do t times t, right? Why? Because tau is t, right? And then I do minus t squared, which is equal to now this one right here is t, right? Now this is t. Now it's become a 2t squared minus t squared, which is equal to t squared. T squared, right? That's the first one. Now, I am going to move this here, and remember that this was actually 2, right? That signal was 2. So now the length of this is 2, right? So when I move this length to 2, I am going to reach the limit, so I don't have to do it anymore, right? I don't have to do it anymore after I reach the 2. Everything right here would be basically 0. I mean, I could, but it's not really necessary. I can get an idea of how the signal will look like after this. So what I will do is move the whole thing to here, right? So I am going to do another. This is 2, right? Now the rectangle is going to be sitting right in the same length with the triangle, right? Because they are the same length, right? That is the maximum. I mean, I guess I will get an idea at that point, right? Where the signal is headed. So this is, okay, so now, you can see that I already covered the whole area. Now the whole thing is, the only area that I am really, really interested in is this, right? That overlapping. Okay, so with that being said, so I was okay, so where am I seeing this already, right? Where? Am I integrating from 0? So, okay, so remember that this is t minus 2, and this is t sitting at 2 right now, right? But this is the tau axis. Okay, so, and this is h of tau, right? Minus tau, and then this one is x of t, s of tau. Everything is respect to tau, right? Right. So now what I can do is integrate from this, but this is sitting at 0, so I don't even have to do anything to that, right? I don't even have to count that. What I need to count is this and this, right? From this to that. So I can say that the integral from 0 to 2, right? Because now t, actually this is t, it's not tau. T is at 2, right? So, and that is the highest limit, so I do 2, and then I do now I get t minus tau again. Oh. T minus tau and d tau. Right. So when I do that, I get the following. I get 2t, right? 2t, and then I get times tau, right? Times tau, right? Minus. When I integrate that becomes again 2 tau squared over 2, right? And that becomes 2 tau. Now, I have to be careful. So this one is, we got 2t times tau minus tau squared, right? So now I am doing from 0 to 2. Right. Now, when I replace that, that becomes what? Becomes, this is 0, so, all right, we apply in 0 over here. This is 0, that's 0. But then if I apply 2, this becomes 2t, right? And then 2 right here minus 2 squared, right? And that becomes 4t minus 4. 4t minus 4, I believe. 4t. Let's see. 4t minus 4. Right. 4t minus 4. Right. So at that point, when this is 1, right? When t is equal to 1, it's going to drop to 0, right? So now, this, how will I look at how that will look in the graph, right? So, so let's see. Hopefully they made a mistake. There's 2. Okay. So yeah, so basically, right, so we'll start like this. So the first graph, looked like this, like a parabola. So it goes like this. This is a 1, right? It's going to be rough to do this. All right, so this, we can call it y of t. That's that guy. So now we go like this. Right. So it looked like a parabola, right? It looked like a parabola, but then it became decaying like this. It looked like a parabola, but then it decays down. So at this point is equal to 0, right? So at that point, the decays down, and this at this point is 0. So that's how, when this is 1, right? When t is equal to 1, it becomes decaying, and it comes to back to 0, right? So right, so Will it look like this when you grab it in MATLAB? Probably not. In MATLAB, will look, it will look like almost like a more parabolic shape, something like that. Yep, something like that, right? So, matter of fact, it doesn't even look like this. It's kind of straight. It goes straight down. So, so basically, that's how we do this, analyze this type of problems. And if you did this again, problem is going to kind of repeat this parabolic shape is going to repeat itself, and that's how we do this problem. Thank you for watching.